Hello, this is Yannis from Any Repair. Today we will go through a repair on a Lenovo Thinkpad E580. The board number is NM-B421 that came to our lab dead with a weird noise. Let's go through this repair and see what we did. This is the board on its chassis. We have plugged in the Type-C charger, and we have a funny noise, like a beep, like a pattern, a beep pattern that starts when we are plugging the charger, and that indicates a fault. We have a broken MOSFET on the sideboard. We have already disconnected the cable from the main board, but didn't solve the problem. So we will remove the board and check on the desk. Here's the board lying on our desk, and with our thermal camera we have noticed that we will see now in the microscope is a little hot or has a little heat on it when we're plugging the charger. This is a very low value, about 20 ohms. In the 5-volt always section, this is a load switch that is connected with the main 5-volt coil that, as you can see, has 20 ohms too. So we are having a short on 5 volts. The drill is to cut the jumper in order to determine which side of the coil has the short and determine which way we will go. So let's cut the jumper using our wick and our soldering iron. We're cleaning the solder from the pads. And now we will check the continuity between the pads we have desoldered. And the next step is to check the resistance to ground between the two sides of the pads. As you can see, we have a good resistance on the coil, but a very low resistance on the far side of the pad. So the short is on the load, and we must check by injecting voltage on the far side pad which component is heating up. Let's do it. We have already connected this jack on the far side pad to inject voltage to see what is getting hot. And now we will see on the microscope that in the area of the 5 volts that was shorted before, there is a component, this one, that is getting hot. Let's put some isopropylic and check again. You see that it is burning. Check again. So we must remove this component and check the resistance. As you can see on the schematic, this component is a USB power switch that feeds USB with 5 volts from the input to the output. Input is the 5th pin and the output is the 1st pin. We will check the resistance on first and fifth pin and determine what we will do next. So let's go and remove this USB power switch with our hot air and our tweezer. Heating up, grab the component and lift it. Now we must check for resistance to ground on the input and the output. The resistance is high enough on the output, but on input it goes low again. It is 20 ohms, so the problem is not solved, although the component is broken. So we will continue injecting voltage with the same DC jack on the same pad to see what is heating up. As our thermal camera showed, this component is getting hot too. This component is the U6402 that, as is shown on the schematic, is a power switch, a USB power switch 2, which have its input on pin 1 and its output on pin 12. Let's go and see what is happening there. So here we are in the area of the interest. We're measuring the ohms that are very low. You can see we have 19.05 ohms and 19.52 ohms in input and output. That is showing that we have a short between input and output. And that indicates that this component is broken too and must be replaced. Let's remove it first and check. We will protect the connector with a shield, and we will heat up the broken component, and with our tweezer we will remove it. Now it's moving, and now it's lifted. So after we will remove our shield, we will check for resistances input and output to check if the problem is solved. So the short seems to be clear, and the output yes, for sure it's solved, and in the input we have 100 ohms, which are better than 20, but it's not what we need in a 5-volt rail. So we have more things to do. So as we're checking further, we have noticed that this controller, this CPU vCore controller, the PU401, has a fade of 5 volts on pin number 13, and of course this chip is controlling the VCC GT, the VCC core, and all the requirements for the CPU in order to work properly. Let's check on the microscope what we're having there. Here we are. As you can see, I have removed the resistor, which is feeding 5 volts on the pin 13, and we must check the resistance to ground on pin 13 with the resistance and without the resistance. This resistance to ground is very low. It's about 1.5 ohms, which is connects directly to the pin 13 on the chip. And on the other side of the resistance, we are having a very good value, which indicates that pin 13 is shorted to ground. The input of the chip is shorted to ground, so the chip is faulty and must be replaced. Value of this resistor is 15.8 ohms, which is not good. I think it is 2 ohms. Of course, with the short, the value became bigger, so we must replace this resistor too. Now let's remove the chip for further testing. With our hot air and the tweezer, we're heating up. We're trying not to knock out anything. We're gentle. The chip is moving and finally lifted. Now it's the time to check for resistance on pin 13. The resistance is very high, as it should. And now the suspect of this short is the chip. And we will take it, turn it upside down and check pin 13 to ground on the very own chip. Let's check the resistance, which is the same as the short, so the pin 13, the input of the chip is shorted to ground internally. We have already our new chip from China after a long wait, about a month, and as it is in our arsenal, we will solder it back. We will try to align it properly after we have added some flux. As we have said, flux is a very good thing to do before and after soldering for reflow purposes. Now we are trying to align the chip properly. The dot is the pin 1. We have a big ground pad on such chips, so we must have patience in order to solder the chip properly, because the ground pad helps chip to transfer the heat on the board and remain cool. Soldering job is done. Now we will press down the chip in order to remove the excess solder from the ground and do some alignment because we have ruined it. Now we're good. Now we will clean up a little bit the flux with isopropylic in order to have a better view on the board, because we must do inspection for the pins on the pads and their soldering state, which should be good in order for the chip to work properly. And I think we are okay. Now that the chip is new, we should measure the value of the resistance on pin 13, which is big enough. And I think we are okay to continue. So we'll solder the resistor back on its place. And then we will test for the circuit if everything is okay or not. Let's go. Heat up the resistor. Put it back where it should be. Knock the other one aside, but I will notice, and then put some flux and solder it back. And now everything is in place, and we can check for the circuit if it is okay or not. We will try to find the coil, the 5-volt coil that we have cut the jumper of it in order to check there the resistance to ground. And we can see that the resistance is high enough. So we can proceed on checking the consumption, the voltage and the amps that as you can see we have a good amount of consumption. Is about half an amp. The fan was spinning but now stopped. But as you can see the consumption is great too. And I think we are good. We will put everything back and come back again. We have used our motherboard to connect the screen only. And now we will find and plug in the Type-C charger in order to power up the notebook and check if we have everything, good consumption and display. The connector is plugged, the charger is plugged, and the consumption is good. Patience, and yes, we have display. The notebook is back to life. The problem is no more.
That was the repair, as you saw. That was a difficult one. Short on the 5-volt rail, which normally it is easy, became a very hard job to do. If you like this video, consider like, subscribe and share. Thank you for watching. See you in another repair. Bye.